tell me your secret plan or your secret campaign that you would like.
Yeah, I mean, talking with many Nobel Prize winners, there was something I discovered after some time is that you can actually buy, when you win the Nobel Prize, you can buy fake, gold-plated, but not gold-made, fully made medals, like for $400 or $500. And
like a replica.
Exactly, it's a replica. And this I would actually like very much to have one or two of them, because I can really see that it does make an impact on kids. They remember the moment and that they kind of feel it was maybe a special opportunity. You need this kind of symbol. And when I go to Paris from Geneva or even abroad, crossing the border I'm not going to bring the Fields Medal for sure. So having this replica would be very practical, I think.
I like your idea of a replica Fields Medal that you can travel around the world with and not fear losing your original. Would you feel like you were shortchanging the children a little bit, saying, come and see my Fields Medal, and they weren't looking at a real one? Would it, there's something about the real thing, isn't it? That's magic.
Aren't we in a world where the symbol is more important than the materiality of the thing? I mean, at the end, basically, the kids, they don't really care about the medal itself. They care about the person they actually listen to for 1 hour 30 or something like that. And so they need something to materialize what it is, but it's not that being made of gold or anything is... and if this is the lie, that's a lie I'm ready to actually produce. It's not a big lie, So.
Hugo Duminil-Copin is awarded the Fields Medal 2022.
It's a good idea. I hope we can make it happen. Replica Fields Medals, please, please. Do you remember when you first heard of the Fields Medal? Do you know when you even knew it was a thing that existed?
Oh, well, I don't remember exactly when. It became more of a thing for me when I was a PhD student, because my advisor, he didn't have it when it started, but he got it during my PhD. So there I got the experience of somebody getting the Fields Medal and realizing what it meant and so on. So in 2018, I go to ICM, I see all these great people having Fields Medal and so on. And then I started hearing rumors that it was actually not that far for me on this 2018 round, which I think I should never have heard about it, because then it starts to be part of your life. And there is this thing in France, are you thinking about it when you shave in the morning? So I don't shave so much, so that was not really. But when it becomes a possibility, it requires additional thinking and additional mental load to actually try that it doesn't impact too much your life. So between 2018 and 2022, I had to be efficiently and actively trying not to think about it and trying not that it impacts in particular my research. So I didn't want it to impact it. And this was a little bit of being careful about it. And so these 4 years were not that nice, in full honesty. Yeah, I remember very well, I will not tell you who it was, but somebody telling me, that people are betting on who will get the Fields Medal. And the person, without asking me permission, just showed me the place and started scrolling the comments. And some of them were actually very mean. And so, you don't ask anything. You just do your research, you like what you do, and you discover this person, of course you don't exactly know who it is, but you can, see that it's not so many candidates, let's say, think that this is not worthy anything, or this is not worth, and this, you just enter in a world that it's not the reason why you do math, it's not the reason why you did enter into research. And so this thing was a little bit heavy, I must say. I mean, that I didn't enjoy so much. And it was coming from a good heart all the time, nobody was directly mean to me, but it just put some pressure that that I didn't want.
Can you tell me the story of how you found the news?
Oh, it was a little bit funny because I received this email from head of IMU. So I know that this is for that, right? But I'm very surprised about the tone of the email that seems worried. And then I discovered that in fact, he sent me a first email before that went into my spam. And so I guess the person was like, oh no, I felt on one that he's going to refuse it, or I don't know. I mean, so that was a funny thing. And then just, you won Fields Medal, just went into the spam. I mean, Gmail decided that this is a spam.
Were you successful at keeping it a secret? Like, because you're not supposed to tell anyone, are you?
I'm not supposed maybe to tell to whom I said, no, but I exactly lasted, I think, 5 minutes with the person that I wanted to talk to tell more, the most about it. So I went to visit him. I was visiting him the day after, it happens to be, and after 5 minutes I told him.
Can I ask, and you describe this how you like, why did you win the Fields Medal? What did you do? What was your work that got you the Fields Medal? And you can explain it at whatever level you wish.
It's something I keep asking myself, because in some sense I have a very different opinion of my work than what was written in the law issue, which for me is very strange in some sense. Like I'm not a theory builder, and I'm not a problem solver, which usually you classify in one of the two. In some sense, that I'm more like I'm rectifying things that bother me. So when I arrived as a PhD student, there was a very well-developed theory of what we call percolation, which is a way of modeling porosity of a medium. And there was a very well-developed theory of what we call independent percolation. Things where you kind of imagine that your medium in different places, your stone, say, whether it's empty or made of stone, is independent. Like if I tell you there is a bunch of a hole here, it gives you zero information on whether there is one here or here. But there was, as soon as you were introducing dependence, like saying that there is a hole here is impacting, like it's increasing or decreasing my probability that there is a hole here, for instance. As soon as you were introducing dependence, the theory was not completely vanishing, but much, much less developed. And for me, it was really bothering me when I started the field. I was asked for my PhD to look at actually very evolved questions, and even the very basic one I was not understanding. So I started developing with my collaborators, like very different people, but trying to develop a theory of dependent percolation. It started developing pretty well, and we got a more and more robust and developed theory of dependent percolation. And I really thought that if there is a reason I get the Fields Medal, would be because of this cumulated body of works leading to a reasonable theory of dependent percolation. Of course, there is much more to be done, but basically something more developed than 10 years ago. Let's take 2 minutes to tell you a little bit more about the problem, because it's not that complicated. So you have your stone, right? And you want to understand where there are holes in it or not, in order to understand how water or a gas, let's say water can flow through it. So what you imagine, for instance, is that your stone is kind of a grid. I'm drawing it planar because drawing in 3D is not my specialty.
But your work did deal with 3D.
It did deal with 3D, with 4D, where there are links to other things. It did look, 2D as well. You can do it in different dimensions. And basically here, what you are going to say is like, okay, I want to model the stone, so I'm going to think that there are holes in it where water can be. So more generally, what you can do is for each hole, you can toss a coin, and if it's face, up, you color it in blue, and if it's tail, you color it in gray or you keep it in white. Just say that the holes are when you hit face. And what you realize here when you do this sampling, can water flow through my stone or not? So for instance, this is my sampling. Is there a path? Here I can say my stone is porous to water, because you can see that there is a path of blue going from top to bottom. It's independent in the sense that if I tell you this is blue, it's because I toss a coin there, but it gives me no information on there, right? Because I'm going to re-toss the coin. So this is Bernoulli percolation. In the sense, it's independent percolation. And we wanted to build a theory of dependent percolation where, in some sense, maybe, for instance, the fact that this is blue, this is blue, this is blue, is impacting what is happening here.
How can it be related?
So for instance, you could imagine, imagine that all those are chosen to be blue. Maybe, you should in this case say, well, this one is automatically blue because, you are not going to have a levitating piece of stone, for instance. Or more generally, this is one way of sampling randomness, like to choose the colors. You could find another one. There are other ways where this time there is dependency, where you can color color a stone or a grid in blue and white. So there are many, many ways, and very natural ones actually involve dependency. And so when we started, for those natural models of percolation, the theory was not fully collapsing, but basically was much more limited.
You're saying, the rock can't float, this is made of rock, or what's deciding what colour's in and that, natural factors and that. This feels real world to me.
That feels real world, but the question is the motivation in some sense. So this is the motivation, but then the model is a model of random graph, basically. It's fully on the mathematical world. And then when people think applications, they think, okay, what you are going to develop in this thing, is it going to impact real world back? And this arrow back to the real world, for me, I have no idea, and
this is not my department.
That's not my department, exactly. I'm participating to an environment where mathematics is produced, and some of this mathematics is going to be useful, but I cannot really say that mine is going to be useful. And in some sense, I want not to think about it because my creativity is going to be led by something different, by a different vision, which is more maybe tool-oriented or idea-oriented than application-driven. So in some sense, I'm very happy with not thinking about these applications. Yeah.
Okay, let me come back to your train of thought earlier. You and others had success here that was significant, and you thought that was going to be the Fields Medal.
Yeah, I thought that this would be basically the thing, which probably was not totally obvious because you couldn't single out one result But in fact, when I learned about the Low-Day show, it was very much focused on some very late result I made in my career, actually pretty recent results, maybe from 2020 or something like that, and which are very much related to another model, not of porous stone, but of magnetism. In some sense, you imagine, a huge magnet, and you want to understand why this magnet, when you heat it, you may lose magnetization at a certain temperature. So if you take a magnet, you heat it at certain temperature, loses magnetization. It's called Curie temperature. And there, the idea is a little bit different, is that you imagine that your magnet is made of a collection of small magnets like that, and that these magnets, they have two mechanisms that rule their behavior. The first one is the temperature, which is kind of telling them how excited they are, how much they are going to listen to the rule. And the other mechanism is actually a pretty natural one, which is that these small magnets, they want to align, exactly like big ones. And by kind of looking at the interplay between this rule that they want to follow, which is alignment, and this excitation, this disorder coming from temperature, you want to understand if they tend to align in one direction or they tend to just do whatever they want, and when they do whatever they want and basically half is pointing in one direction, half is pointing in the other one, you lose magnetization. The global magnet in some sense is half the small ones are pulling in one direction and the other half is pulling in the other one, so it cancels. And this is the model, the Ising model. And
this feels...
Again,
this doesn't feel like mathematics. This feels like physics.
I hear what it comes from physics. These two models, they are motivated by physical systems, and they were sometimes, in this case, for instance, is the Ising model. It was invented by physicists, but then you can study them mathematically, and there were a body of works. In particular, in 2 dimensions. And very little was known in 3 and 4 dimensions. 3 dimension is the dimension of your magnet, so this is interesting. And 4 dimension is actually related to quantum field theory, so to physics again. And so we produce results in 3 and 4D for this Ising model. And this was like the beginning of the Low Show was really about that.
I know you said you were never aiming for the Fields Medal. It was never a goal or a finish line for you. But it is like a crowning achievement of one's career. Like, you know, when you are introduced, when you are on a poster, when you walk into a room, you're the guy who won the Fields Medal. It's become like a big part of your career, surely. Surely.
Yeah. But
So how do you go on from that? How do you keep motivated? What motivates you to keep doing great things?
the same thing as before. That's the point. Is that, I mean, in some sense, it doesn't change the reason why you do research. It's so I still, you know, I mean, on the 4th, or I don't remember if, yeah, it was the 5th of July. On the 4th of July, I had a problem I wanted to solve, and on the 6th, it was still there. So in some sense, you keep trying to answer the question that you ask yourself, and this doesn't change anything. The price is actually not giving you fulfillment from that point of view, and it never will, and the next price will not. If it happens or not, I don't know. But I mean, the thing is that it's really, it doesn't change your mental approach to mathematics. And I still have the problems I want to solve. Yeah, maybe people will not think they are the most important problems, but I mean, before the Fields Medal, they didn't think that either for most of them. So I mean, anyways, importance is what I feel is I want to solve or I want to answer. This didn't change with the Fields Medal at all.
I often ask mathematicians at the end of the videos to sign the papers for me, and I always joke to them, will you sign the paper, because one day if you win the Fields Medal, these will be worth more money. You actually have got a Fields Medal, so I don't know how you're going to make these worth more money.
I mean, I have 2 papers, so I'm going to be able to show you one regret I have.
Okay.
So this is my signature that I thought was, you know, a great signature to have.
Whoa,
when I was a kid.
You can't have a signature that complicated when you have to sign lots of work.
Exactly, and I understood that very, very much the first time I gave a talk in front of, I gave hundreds of talks now in front of kids. These are the best ones to give. And kids, like at the end of a talk to kids, like say to middle school, there is like 3 possibilities. First possibility, everybody leaves, and you are like, okay, well, it's done. Second possibility, everybody is about to leave, but somebody comes and asks for a selfie. And then, if this happens, then you have 100 kids lining up for a selfie. And this is fine, it's cool, blah, blah, you need to smile. And now, apparently, I have this smile that it looks exactly the same on every picture. But there is a third possibility, and this one is a painful one. Is that somebody comes and asks for an autograph. And then you have 100 kids that want an autograph. And this really is helpful when you have this kind of signature. Yeah. So then I decided that my new signature was that. And this is like the young me is dying, but the old me still has a rest thanks to that. So yes, my 2 signatures.
You can catch a longer and different edit of this interview on the Numberphile podcast. I'll also put links down below to Numberphile interviews with other winners from Hugo's class of 22.
I sort of have it locked in a box at home, which means I don't actually see it very often.
Plus interviews with fellow French Fields medalist Cedric Villani.
Then the phone rings. Hello?
And watch the moment I borrowed a Fields medal in order to impress people during a speech at the Royal Society.
But I know a guy. For me? Am I being awarded the Fields Medal? Oh, well, thank you very much.
As I said, links down below to all this and even more. Check it out.
Lecturers do and teachers do. This happens all the time. And he crossed it out and just got on with what he was doing. Cracked on. But I stopped him. And this was before he'd won the Fields Medal. But there were lots of rumours that he might get one because he was doing some good stuff. And I said to him, you know, James, if you ever win the Fields Medal, I'm going to have this piece of video of me correcting your mathematics.